We're going to talk about solution concentration, which we use the term molarity to describe. So molarity represents the number of moles of solute per liter of solution. And if we look at this solution right here, we can see that it has a concentration of 0.861 moles per liter. And you can also see that we have about approximately half a liter of solution. So a question I might ask you about this, I would say, how many moles of solute cobalt nitrate do you have dissolved in this solution? And what you would have to do is use dimensional analysis, and you'd say, okay, what I know is I have half a liter of solution, 0.50 liters, and I know that for every 1 liter of solution at this concentration, I would have 0.861 moles of the solute. So all you would have to do is realize that the liters of solution would cancel out, and that would leave you with the moles of solute. And you would find that you would have in this solution 0.43 moles of cobalt nitrate. Another thing we're going to talk about today is dilution. So dilution is when you either add water to the solution and the concentration will go down proportionally. We could also concentrate the solution by evaporating some solvent, and that would make the concentration increase. And the equation that you would use for either one of those processes is M1, or your initial molarity, times your initial volume, is going to be equal to your final molarity times the final volume. So a question I could ask you about this solution would be, how much water must be added to the solution to reduce the concentration to 0.60 molar? So here we have a final concentration, and we already know our initial concentration is 0.861, and our initial volume is half a liter. So what we would do is we would take this equation and we'd rearrange it to solve for the final volume. The final volume would equal your initial molarity times your initial volume divided by your final molarity. So you plug in the values and you see that you would have 0.72 liters of solution that you would need to have in order to dilute the concentration from 0.861 to 0.60 moles per liter. So that's not our final answer here because that's the final volume. I asked you in the question what volume needed to be added. So the volume added is going to be equal to the final volume minus what you started with. And you can see that 0.72 minus the 0.5 liters you started with means that you would have to add 0.22 liters. Now before I move on, I just want to talk about a couple things that we can do to manipulate the concentration. So first is if I add more solute, your concentration goes up. See? Yay. Now if I evaporate some of the solution, that will also make the ratio of the amount of moles of solute to the space occupied by the solution increase as well. And if I add water to it, it's going to dilute it. So those are the ways we can impact the concentration. If I drain out some of the solution, there's no impact on the concentration whatsoever.